Hi, welcome back. Hearty welcome to you. In this session, we will go through solution of simultaneous linear equations. As part of that, we will look into Cramer's rule method to solve simultaneous linear equations. We have 2 to 3 methods. What we are going to cover, one is Cramer's rule, then we have matrix inversion method, then we have Gauss-Jordan method. These are the methods which we can use to solve the simultaneous linear equations. We'll briefly touch upon Cramer's rule and what is the formula to be used to solve with the help of Cramer's rule in this particular session. Okay, now let's go ahead. We have three equations, simultaneous linear equations: a1x plus b1y plus c1z equal to d1, and similarly a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. Now I can write this in matrix form, as you will agree. I can write it as we have seen that earlier. Quotient matrix I can write a1, b1, c1, a2, b2, c2, a3, b3, c3 into x, y, z equal to d1, d2, d3. Now we have to find out how to find out the solution. Means we have to find out the values of x, y and z, right? Now let us see how to find out the value of x. For that, what we will do, we'll start saying that determinant delta is nothing but equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay. Now I have to leverage whatever I have here to find out the value of x. So you can see here, if you look at the first row, a1, b1, c1, so I don't have x, y and z. But if I am able to multiply the first column with x, then I can say transform this column, first one, yes, c1 is assigned c1 plus c2y plus c3z. I should be able to get whatever the total equation I have, a1x plus b1y plus c1z. Okay, so what I will do now, next thing is I'll multiply with x into delta will give me a1x, a2x and a3x. You know that if you are multiplying determinant, you have to multiply either a row or a column. Yes, so b1 c1, b2 c2 and b3 c3. Now what I am saying as earlier is I want to convert this first column into a1x plus b1y plus c1z, because I have already a1x, b1 and c1. If I multiply this with y and multiply this with z, I should be able to get, then I can replace them with d1, d2, d3. Then I divide by delta, I will be getting the value of x. That is the way we want to proceed. Okay, so x into delta is equal to, I will say c1 is assigned c1 plus c2 into y plus c3 into z. Then I will have a1x plus b1y plus c1z. Similarly, I will have a2x plus b2y plus c2z, lowercase. Z is a3x plus b3y plus c3z, and remaining columns I'll have as it is b1, b2, b3, c1, c2, c3. Now you can see that these values are nothing but equal to d1, d2, d3. So I can write it as d1, d2, d3. Remaining I'll have as b1, b2, b3, c1, c2, c3. If I take this determinant as delta 1, this whole thing, then I can say x into delta equal to delta 1, that's nothing but x equal to delta 1 by delta, where delta 1 is equal to determinant of nothing but d1 b1 c1 d2 b2 c2 d3 b3 c3. Now you can take this same quotient matrix and try to apply two transformations for me that I will tell you to find out y. What we should do to find out y? To find out y, what you have to do is first multiply by y c2, then transform c2 as c1x plus c2 plus c3z. You will get y equal to delta 2 by delta. Similarly, you will get z equal to delta 3 by delta. Now what are the values of delta 1, delta 2, delta 3? Let's write them here. I will repeat the same thing here. X equal to delta 1 by delta, y equal to delta 2 by delta, z equal to delta 3 by delta, or you can write it as x by delta 1 equal to y by delta 2 equal to z by delta 3 equal to 1 by delta. Now what are delta 1, delta 2, delta 3? This is important. You can observe, you have the quotient matrix. In delta 1, when you want to find out x, what you will do is, your first column, because you are finding out x, that first column will be replaced by d1 values, d values. It will be d1, d2, d3, b1, b2, b3, and c1, c2, c3. What will be delta 2 in the same lines? Delta 2 is second column, right? So the first column will remain as it is. Y value is second value. So here you will have d1, d2, d3. You can observe that because what we did, we transformed the second column. Now that will be c1, c2, c3. What will be delta 3? Delta 3 equal to, now you are looking into third column, so remaining columns will stay as it is. a1, a2, a3, b1, b2, b3, and you will have d1, d2, d3. So it's very simple. Let's solve some examples using this Cramer's rule in the next session. So what we did in this session is we have touched upon Cramer's rule and we found the formula how to find out the values of x, y, z, which will be solutions of simultaneous linear equations. In the next session we will do couple of examples using the Cramer's rules method. Thanks for visiting. Bye for now. See you in the next session.